It's kind of random sometimes. Okay. So let's call this f of x, just a parabola opening upward. And then the second curve you're going to get is something like a straight line. We'll call this g of x. So f of x is this curve, g of x is that curve right there. And what you're looking for is the area between the two curves. So it's kind of like this moon shape in there. That's what you're looking for, right? So I think it stands to reason that you would have to find the intersection between f and g, right? So if I give you two equations and I say, where do these two curves hit each other? What do you do? If I give you two equations and I say, where do they hit? What do you do, Shannon? Yeah, you do a system of equations. Or just set them equal to each other, right? It's just basically a system of equations. You plug one in for the other one, right? And then set it equal to 0, and then t it or factor it or whatever it needs to be done. I promise you that's not going to be the tough part, right? But I'll go through some of these together with you. Now, so once I find those points of intersection, we'll call this A, and we'll call this B over here. Tell me if this makes sense. First, what we're going to do is we're going to find the area underneath g of x. Going from left to right. And to write that in calculus speak, Olivia, how do you write that?
A to B.
Yep. And just a word about notation. Do you guys agree this is nothing more than like the summation thing, basically? Here's the height of every one of those rectangles. Here's the width of every single one of those rectangles. They're all super, super thin. Dx means really tiny. So it's like an infinite number of really thin things. Okay. So that's going to give you, though, too much area, isn't it? I'm going to give you like all of this. So in order to get just the area between the two curves, I'm going to subtract out the area that I don't want. And I don't want the area underneath f of x. So that's what I'm going to take away. I just take this and then I subtract out the integral from a to b of f of x dx. And that then subtracts out all of this, right? What I'm left with then is just the area between the two curves. That's really what I'm looking for. Now, I will tell you this. You don't need to write this twice. You can just write this like this, right? The area from a to b of g of x minus f of x. Because you guys agree, right? If you have subtraction or addition, you can split them, but we're just putting them back together, essentially. Okay. Cool. Then, there's something different in chapter 6 about what we did in chapter 5 and chapter 4, so we need to talk about that right now. Is this logical? I think it is. It's pretty easy to see. All right. So put this in your notes if you would. Area between curves will always be positive. If you are getting a negative number, there's something wrong. Now, in chapter 4 and chapter 5, there were times, wasn't there, when you would integrate and find area and you would get a negative number. Abby, what was happening there? It was under the x-axis, right? So let me just show you how it's going to be different in chapter 6 than it was back then, okay? So let's do something like this. Let's do this curve right here. So let's do f of x is equal to x squared minus 4. So this is negative 2, this is positive 2. Do you guys agree that in chapter 4, if I integrated from negative 2 to 2 of x squared minus 4 dx, I got a negative number? Because it's below the x-axis. In chapter 6, this is only one curve. Chapter 6 has two curves. So if I'm looking just for this area right here, do you guys agree that the upper curve is this curve right here. So the difference is this. So this is like chapter 4/5. In chapter 6, I'm going to do this. I'm going to do the integral from -2 to 2 of 0 minus x squared minus 4 dx. I have to have two curves. So doesn't it make sense that this is a negative number, and now suddenly it's positive in chapter 6 because I have that second curve. Is that good? All right, sweet. So I think none of this is really hard to understand, especially in 6.1. It gets a little more complicated when we get into 6.2 on Monday, but for today, I think it should be pretty good. What do we think? We doing okay? All right, let me give you a slightly more complicated picture. Questions? Andy, you okay? Yeah. All right. Sweet. Okay, guys, the important part is to make sure that you don't miss points of intersection because of a picture that looks like this. Call this f of x, we'll call this one g of x. So if I'm looking for the area contained between the two curves, I'm looking for this, I'm looking for that together. By the way, one thing I failed to mention before is you will get positive area as long as you are doing upper curve minus lower curve. Has to be upper minus lower. It doesn't matter where they are. They can both be below the x-axis. Upper curve minus lower curve every single time. Which is why this is an issue, right? Especially if this curve is f of x. Let's make it round. Because they switch places, don't they? Okay, so let's go ahead and write this out in the correct order and tell me how to find just this area right here. Oh, let's go from A to B over here to C. Go for it.
So A to B.
Yep.
F of x minus g of x.
Beautiful. And then I'm going to take that and add it because I want that area plus this area. Keep going in.
Okay, so to derive B to C.
Yep.
And you have g of x minus f of x.
You got it. You got it. Do you guys see the problem? I can't go from A all the way to C, right? Because if these are in the wrong order, isn't this going to be negative? Right? If I do G minus F, I'll get the same number, but it'll just be negative, won't it? Won't it? All right, now hang on here. We're assuming that these are in the correct order. Let me put some numbers on here. Let's say that this is area of 10. Let's say this is an area of 12. Do you guys agree that when I integrate from here to here, from A to B, I'll get an answer of 10, and over here I'm going to get an answer of 12. So the whole area is 22. How we doing, people? We good? So just remember, you can't skip points of intersection, and if you don't skip points of intersection, you should be good every time. All right, Cassie, you hanging in?
Yeah.
Okay, now, every single one of these problems, you guys, I have given you the graphs. On the problems I'm going to give you tonight, you're not getting the graphs. So doesn't that then become an issue of which one is upper and which one is lower? You guys with me? All right, here's what I'm going to suggest to you. I'm going to save you a little time on the homework tonight. Okay? I'm going to tell you that you don't really need to worry about the order. As long as you're not skipping points of intersection, you just do this. Let's keep the order the same. And I'm just going to do f of x minus g of x. When I do that, I'm going to get an answer of negative 12. So all I do is absolute value it, and I'm good to go. I get 22. The reason that's nice is because then you can use the same antiderivative. You just plug different numbers into it. So it saves you a little bit of time. Olivia, you doing all right?
Yeah.
You sure?
I'm just looking at it trying to get it. It's like, it makes sense, I'm just, the order is weird, and like the upper.
So-
kind of Weird.
Here's what I'm saying. As long as you have the points of intersection, right?
Yeah.
And you're going from one to another, you're not skipping or leaving any of them out, and you go from left to right. What I'm saying, I guess, is,
I just go from left to right.
yeah,
How?
for these bounds here, just make sure you go left to right. So you gotta go lowest, next lowest, pick up at that next lowest, and then go to the most upper. You
So
should.
that's what you mean when upper is that you're going left to right.
That's what I mean when I say go to left to right.
Well, that you're going up, that makes sense, but by upper, like the upper curve.
Oh, sorry. We're talking about two different things, I think. So check this out. A, B, and C, when you set one equal to another and solve it, you just have to make sure that those are in the correct order, right? Going from low to high.
Okay.
When you anti-derive, you can do it in any order you like. It's just that if you get a negative answer, make it positive.
Okay.
Because you could have them backwards, right?
So if you know the lower one is negative.
Yeah, because look, if you just do, like, if I flip these, I will get an answer of -10. Like if I did G minus F, I get the same number, it just has a different sign on it, which is why you don't really need to worry about it. I'm gonna work through one now,
Yeah.
and I think that'll help you, okay? Because I know all the A's, B's, and C's, and the F's, and it all looks weird. So let's actually do one, okay? And I think, Olivia, that'll get you to where you need to be. Okay. So let's do. Okay, let's do this one. So I got f of x is equal to 3x cubed minus x squared minus 10x. Let's do g of x is equal to negative x squared plus 2x. So don't spend any time trying to graph them. Doesn't matter. I'm gonna have you do these without a graphing calculator. All right. So what's the first thing we're looking for? Perfect. I'm gonna set one equal to another, right? So I get this. 3x cubed minus x squared minus 10x is equal to negative x squared plus 2x. What do we do now? Like it. How are we gonna do that, Casey?
Rearrange.
I like it. Rearrange it. Let's move all this over here. Good. So this is gonna be 3x cubed. Okay, here's what I'm gonna do. I'm gonna add x squared to both sides. And I'm also gonna take away 2x. Let's do it all together, okay? These go away. I get negative 12x. This cancels, that cancels, I just have 0 over there. Now what do we do? Take out
X.
and how about a 3? I like it. That gives me x squared minus 4. Then what do we do? Solve. So tell me some x values.
0 plus minus 2.
Love it. You just got to be careful, right? When you undo an even power, you get plus and minus. Because if you leave one out, you are not, this is going to be a train wreck. You're not going to get it. Okay. 3 points of intersection. I need 2 integrals, don't I? Just like the picture I just had before. Cool. All right, here we go. All right, now, right here. So here we go. This is going to be the antiderivative of, first I'm going to go from -2 to 0. And then I do f of x minus g of x. So everybody stick with me here for a second. Don't I already know what f of x minus g of x is? Isn't it right here?
Yeah.
You used that technique to solve it. Didn't I just take f and move it over here and just subtract it? When you set it all equal to 0, you have the expression already that you need. So isn't this just going to be 3x cubed minus 12x dx? And I'm going to add this then to the integral from 0 to 2. I'm just going to do it again. this is what I mean by the fact that you really don't care what order it is. I know probably that one of these is going to end up being negative because I subtracted them in the wrong order. All I got to do is just absolute value that one individual. All right. Olivia, is this helping?
Yeah, no, makes
All right.
sense.
Sweet. It's anti-derivative. What is it? I know.
Two.
What? Sure you're going the right one?
Oh, yeah.
And the nice thing is, since I'm reusing it, I just copy it down again. It's gonna be plus 3/4 x to the fourth minus 6 squared, going from 0 to 2. Thank you, Shannon. And then I just wait for Shannon to tell me what I forgot to write. Thank you, thank you, thank you. And then I'm gonna plug in 0 first. Minus then the lower. Then on the second one, I plug in 2 first. And then subtract out. Get with 0 plugged in. Fun with fractions, this is nothing, right? This is minus 16, I think that's 12. I forgot the square here, 2 didn't I, Shane? What the? Minus 24. Plus 12 minus 24. 0. So check this out. Isn't this negative 12? And all that tells me is that this was in the right order. I'm guessing this is going to be negative, and it is. Means my answer is going to be 24 because you want an absolute value. How we doing? We good? Sweet. I'm going to show you one more thing, and I'll let you guys start out and get after it. Okay? This is essentially all 6 ones. So it's solving, integrating, plugging in. It's not too bad. All right. If I had something like this. It only looks horrible because there's Y's in it. You work it exactly the same. Or what you can do is just make these X's. If the Y's bother you. It bothers some people. Whatever. What's the first thing you're looking for? Okay. How do you solve that? No, I think there's a solution.
0.
Yeah, I think there's
1.
one. I think there's, yeah. Okay. We should be more sure though. Square both sides, okay. You heard me. Bring this over here. You heard me. Take out an X. You heard me. Give me an X value.
0.
Okay. Oh, -1?
Wait, never mind.
No.
I don't think so. They give you
Not
-2.
my attention.
Don't listen to Shannon. She's a liar. Okay, so it's 0 and 1. So how about this, guys? You only need one integral. Integrate from 0 to 1. You could do root x minus x squared. Easy as pie, man. All right.
You get the day off.
It's been a good one.
Yeah, you
I
did.
just asked
The
you.
teacher
No,
worked
I
it.
was really sad about it.
I know.
I don't know.
We could have pies in class.
Yeah, there's my thing is like, I don't know, like eat mayonnaise out of the container.
Yeah, or